Okay, so this is the first part of our factoring lessons. I'm going to talk about factoring trinomials with a leading coefficient of 1 or greater, and I'm going to show you how to factor using the grouping method. All right, first to be able to do that, I just get a couple definitions down. You can pause your screen and write this down if you'd like. To factor means to write something as a product or a multiplication problem. Another way of thinking about that is to undistribute, so you're working backwards. Another way of thinking about that would be to do the opposite of simplifying. So it's like taking the answer and then working backwards to the multiplication problem that you would have distributed to try to simplify. All right, so let me show you what I mean when I say greatest common factor. Greatest common factor is the largest number and variables that will be able to be divided into each of the terms of the expression and not have any fractions as the result. So it's an expression that can be divided into all of the terms of the polynomial. So I'm looking for the greatest one. Well, I know I've got a 6, I know I've got a 12, I know I've got a 14, and I've got a lot of factors of each of those. But really, I focus on the smallest coefficient because those are the only ones that are going to work for 6 anyway. So that's kind of helps me narrow down my options. The factors for 6 are 6, 3, 2, and 1. Those are the four numbers, the four integers that I can divide by and not get a decimal. So what I'm doing is I'm going to check 6 into the other two coefficients. 6 can divide into 12 and I get 2, that's good, but 6 cannot divide into 14 and give me a whole number, so I'm not going to use 6. 3 can divide into 12 and give me a 4, but 3 cannot divide into 14 and give me a whole number, so that's not going to work. However, 2 does divide into 12 and give me 6, and divides into negative 14 and gives me a negative 7. So I'm going to use 2 as the number portion of my expression that's the greatest common factor. So I know I'm going to have a 2 as part of that GCF. Next, I move to the variables. Every single one of these terms has an x in it. The first has an x to the fourth, the second has an x squared, and the third has an x to the third. So they all have at least x squared as part of their term. So that will be part of my greatest common factor, the greatest number that they all have in common. Next, all three terms have a y. The first has a y to the first, the second has a y to the second, and the third has a y to the third. So they all have at least a y to the first. So now here is the undistribute, or the opposite of simplify part that I was talking about. I asked myself, okay, what would I multiply 2x squared y by to get 6x to the fourth y? Because I'm working backwards. I'm trying to find the multiplication problem that I would have to distribute in order to get what I originally started with. I'm working backwards. So what do I multiply 2x squared y by to get 6x to the fourth y? That would be 3x to the second, and since they both already have a y, I don't need a y. Next, what would I multiply 2x squared y by to get 12x squared y squared? 2 times 6 is 12. I already have the correct number of x's, but I need one more y, so 6y. What would I multiply 2 by to get negative 14? Negative 7. What would I multiply x squared by to get x to the third? That would be x to the first. What would I multiply y by to get y to the third? That's y to the second. And this would be my factored form of that trinomial. Next, we're going to talk about factoring a trinomial that's in standard form, and we're going to use that idea GCF to be able to do that. All right, so I'm going to give you a detailed process here to help you with this. So the first thing we're going to do is we're going to multiply the leading and the final coefficients. So we're going to multiply 1 times 12, because what I'm going to end up doing is I'm going to end up breaking apart this middle term and turning this from a trinomial into a 4-term polynomial so that I can make 2 groups. Okay, so I'm looking for factors of 12 that add up to negative 8. Well, the fact that they multiply to give me a positive number but add up to give me a negative number indicates that they're both negative numbers. So what are all the ways that I can multiply two negative numbers and get 12? Well, that will be negative 12 and negative 1, negative 6 and negative 2, negative 4 and negative 3. And so now I ask myself, okay, which of these pair of numbers will add up to give me negative 8? And that would be negative 6 and negative 2. So now I'm going to break apart the middle term or uncombine like terms. So I'm going to rewrite this as a 4-term polynomial. X squared, and now I'm going to rewrite negative 8x like this. Negative 6x plus negative 2x plus 12. And that's how I'm able to uncombine like terms. Now I'm going to group this so that I have two pairs of numbers that I could concentrate on to get the greatest common factor. Again, I'm undistributing, so I'm working backwards to find the multiplication problem that I actually distributed to get the original problem here. All right, the greatest common factor of the first binomial, the only thing they have in common is this x, and they both have at least one x. So the x is the greatest common factor. What would I multiply x by to get x squared? 1x. What would I multiply x by to get negative 6x? Negative 6. Move to the second binomial, keeping the plus sign to separate. They both seem to have a negative 2 in common, as I could divide both of these by negative 2 and get a whole number. So I get a negative 2 out front. What do I multiply negative 2 by to get negative 2x? Well, that's an x. What do I multiply negative 2 by to get positive 12? That's a negative 6. And this is what I wanted to happen. An indication that I've done this correctly is that I get a matching binomial for both of these. A matching binomial for both of these. So that becomes my greatest common factor, x minus 6. And now, if I took x minus 6 away from my left side, all I would have is this x remaining. And if I take x minus 6 away from my right side, all I have is my negative 2 remaining. And now I've found the two binomials that if I multiplied them together, I would get x squared minus 8x plus 12. This is how you factor a trinomial. All right, now I'm going to factor one of these trinomials that has a leading coefficient that's not a 1. So real quick, we still multiply the a and the c values, the front and the back. So 2 times negative 60 is negative 120. So now I'm looking for the factors of negative 120 that add up to positive 2. Well, I mean, you could start picking out a few right away, negative 120 and positive 1, 120 and negative 1. But gosh, those are a long way apart, and when you add them together, you're nowhere near positive 2. Well, that probably means is you need factors that are pretty close together that when you add them together, you end up with a small number. So you're thinking about factors that are close together. 60 and 2, no. 30 and 4, no. But gosh, what about negative 12 and 10 or even 12 and negative 10? One of those are close together, and one of those, if I add them together, it's positive 2. Sure enough, this pair right here. So I'm going to uncombine like terms by breaking apart that middle term and rewriting it as 12x and negative 10x. So here we go. 10x squared plus 12x plus negative 10x minus 60. So now I've got my 4-term polynomial, and I'm going to go ahead and group the first two and the last two, and I'm looking for the greatest common factor of each. So the greatest common factor of this first one, I can divide 2 into 12. I also have an x for both, so 2x would be my greatest common factor. What I'll multiply 2x by to get 2x squared? X. What I'll multiply 2x by to get 12x? 6. Keep my plus sign to separate. What do both of these have in common? Well, I can divide negative 10 into both. And again, I'm looking for the biggest number. So is negative 10 the only one? No, but it's the biggest one they have in common. So I pull out a negative 10. What do I multiply negative 10 by to get x? 10x, just the x. What do I multiply negative 10 by to get negative 60? Positive 6. Now, again, I know that I did it right because these two binomials match. That's the greatest common factor. So I pull that out. What's left over if I take away the common factor of each? 2x on the left and negative 10 on the right. That's the binomial that if I multiply it out, I would get back 2x squared plus 2x minus 60. Now, as you continue to learn how to factor, you're also going to keep looking for any common factors that might show up in here. And one of the things that you might recognize is that in this binomial, we've got a 2 and a negative 10, and they both have a common factor of 2. So I could take this one more step further, and I could pull that 2 out front, and then I have x and a minus 5 left over, and then here's my x plus 6. So if I multiply all three of those, I would get the original 2x squared plus 2x minus 60. I do not want to leave any common terms inside the binomials before I finalize my answer. Okay, something like this where I'm missing the middle term is a special case. And special cases actually factor in the same way every single time. This is called a difference of two squares, and it actually factors as conjugate pairs. But instead of having to memorize a brand new process, I'll just show you how to do this through grouping. So if I rewrite this as a 3-term polynomial, I would just create a middle term using a 0 coefficient, because 0 times x is just 0. So these two, this trinomial and this binomial, are the exact same thing. So now I can go through the same process that I've been doing since earlier in this video. So multiply the a value and the c value. 1 times negative 25 is negative 25. Now I need the factors of negative 25 that when you add them together, you get 0. Well, gosh, when you add two things together to get 0, they must both be the same and different signs. Are there two numbers that I multiply by themselves to get negative 25? I think that's going to be 5 and negative 5. You could test all the different factors of 25 to find these out, but these are the ones that you need. So I'm going to break that middle term apart, and I get x squared plus 5x plus a negative 5x minus 5. Group the first two and the second two, and now I'm pulling out greatest common factors. They only have an x in common in the first binomial. What am I left with? X and 5. In my second binomial, they both have a negative 5 in common. So what am I left with? X and a positive 1. Because what do I multiply negative 5 by to get negative 5? Positive 1. Oh, I made a mistake. Let me go back. What do I multiply? I've caught my mistake. I needed to have a 25 here, which would make this a 5. Pardon my error. Now, what do I multiply negative 5 by to get negative 25? Positive 5. I knew that I made a mistake because these two binomials didn't match earlier, and that's how I was able to go back and catch my mistake. So now I pull out the x plus 5 because that's the common factor. And then what's left over, the x and the negative 5, those are the binomials that if I multiplied them together, I would get x squared minus 25.